Oh, I guess I need headphones. I don't know. The sound canceling is pretty good these days. I don't know if I
You
need
sound fine
headphones.
to me, but
And you're not getting any kind of echo.
No, not at all.
No. Yeah.
Good.
So I did. We're live, by the way. I dropped the hammer and purchased a new MacBook Air, one of the new M
fancy
MacBook.
schmancy.
Yeah, yeah. Well,
Mhm.
they're. It's kind of ridiculous. They're super cheap compared to other ones, and they're ludicrously fast. They they essentially rebuilt the entire architecture of their computers to use. They're like fancy iPhones now. So the new MacBooks are all fancy iPhones.
That does not sound appealing.
It
The ARM-based ones.
Yeah, they're ARM. So they're ARM
Okay.
based. They're a RISC chip. They're ARM based. So it's mental, and it's essentially an entirely new paradigm in computers. They are so a $600 Mac Mini is faster than a $5,000 quad core Intel monster, and they've just gotten started. So it's how the battery life on these is like 20 hours.
No way.
Yeah, yeah, it's crazy. No fan. They don't run a fan. They just like the fan never spins. There is no fan, so they're silent.
Mm.
Yeah, and I'm just I'll just be super clear about this. I hate Macintoshes. Like I just hate them. Like every second that I spend using them is just like static electricity on my fingers, and yet I can't resist.
Are they converting you?
I used them before. I used to have one before, and I just I had to put it in a bag and leave it outside every night because I just didn't want to be around it anymore. So, and you know, but apparently these things are they're ludicrous. So I've got to find out for myself.
No. You're
Yeah.
gonna leave me in the dust. I'm a firm PC person.
So am I. No,
Like
no, I mean, I hate
I'm not
PCs
gonna be
too.
converted to Apple
No,
products.
I mean, I
Not
think it's important
happening.
to hate everything. Like that's got to be your
Oh,
default
that's
position
nice.
in terms of computers.
How old are you, Fraser?
Yeah.
This is a very old man.
I hate everything.
I hate all computers. Yeah, get off my lawn, computers. No, I think anyone with a computer science degree just hates computers. Like I think it's just like they're just like an awful hammer that doesn't work the way you want it to.
It's
Imagine,
not anyone with a computer science degree. It's anyone who has to do programming as
Yeah.
part of their job hates a computer.
Sure,
'Cause
yeah.
Most
Anybody who
astronomers hate computers too.
anybody who has to use a computer for any amount of time, just like wishes they were in the construction industry. Like, when you take a hammer, you pick up your tool, you use your tool, it works the way it's expected. A computer, maybe it does, maybe it doesn't. Who knows? Today
No,
might
the
not be your
thing is
day.
it works the way that you tell it to work, but you have to know to tell it to do
Yeah.
the right thing. So
Yeah. Yeah.
That's a programmer's point of view. I think as a
Yeah.
from,
Yeah.
from a technician's point of view, it works the way somebody somewhere in the design chain told it to work, but it wasn't
Exactly.
me.
Yeah. All right, I got to say hi to a bunch of people. Hello to Six Bob Ohms, Andrew Planet, Andy Cowley, Astro B, Bob Moeller, David Dunn, Frank Tippin, Ian Farquharan, Jay Broder, Johnny J, Larry Beckham, Larry King, Nancy Graziano, Rich Wilson, Scott Bragdon, Sir Goosey, Susan Hunter, Wayne Francis, and Zappan Zappan. Hey, everybody. Oh, I got to do a quick announcement before we get into the show part, which is that I know I'm sort of kind of small and backwards. Okay, you know what? I'm going to shift to just me for a second here. All right, so I've got an interview with Professor Emeritus Wallace Arthur tomorrow morning at 8 a.m. Pacific Standard Time. And he wrote a book called The Biological Universe, Life in the Milky Way and Beyond. He believes that there's life everywhere and explains how that's almost inevitable. And so it should be a delightful conversation between the two of us.
that sounds awesome.
It sounds super awesome. Yeah, I'm really enjoying the book. I've learned a ton about just like life and sort of all of how uninhabitable most of the universe is, how uninhabitable the Earth is, but then like how convergent evolution has just led life to figure out the same thing again and again and again, and how that tells us that the kinds of life forms that we see here on Earth, under the influences of gravity and water and temperature and chemicals, we should see similar kinds of things on other worlds. You know, trees have evolved the equivalent of a tree has evolved multiple times.
Haven't crabs evolved like 10 different times throughout our history?
Sure,
Like
yeah. Yeah.
like the world just keeps evolving into crabs, right?
Yeah. Beetles, right? The world
They just
loves
keep
beetles.
happening.
Yeah.
Over
So
and over again.
and so it gives us this, you know, seeing the way life has solved this problem again and again and again here on Earth, all these problems in the same ways, gives us a really powerful way to predict what kinds of life forms we should see on other worlds. So yeah, I'm pretty stoked. All right, and so also before we get into the episode tonight, just a reminder that today we have an interview. So we're going to, and it's a pre-recorded interview. So we're going to be doing the show part first, talking about the news, and then we'll go into the interview, and it's about 20 minutes long. Again, super exciting. It's Olivier Witasse, who is the project manager for the JUICE mission, which is going to be the other spacecraft that's going to visit Jupiter's moons, especially Ganymede, which, not going to lie, I'm a little more stoked on Ganymede than I am on Europa these days.
I have to say, you shouldn't call it the other Jupiter mission. I mean, like, it's freaking awesome on its own.
Yeah. Not well. I mean, the other one in
The other one.
in
That other Clipper
the Europa
one.
Clipper. Yeah, there's
Whatever.
one that's going to one place, and then there's another that's going to go to all the places. So yeah.
So I feel like
Especially
Clipper should be
Ganymede.
the other Jupiter mission.
Did you know that Ganymede is the only other place in the solar system with a permanent internal magnetosphere?
I did.
Yes.
No.
Yeah. So
Ooh.
Ganymede for the win. Yeah. Europa's old news. All right. I'm going to put you guys all back into the boxes, and we will begin this
Showing
episode.
Europa there.
You didn't think I would go there? You know, I am so fickle.
You are.
I do. I don't.
Pick a planet and stay there.
Pick a world. Yeah.
Pick a world.
All right.
Give it all your love,
Here we go.
like I do with Neptune.
That's it? Neptune's your favorite?
Yeah,
Oh. I didn't know
that's
that.
no secret. I talk about it all the time. Like, you literally can't get me to shut up about it.
Really? So you had to push one into the sun? Europa?
Mars.
Really?
Oh, yeah.
No, Venus.
Sorry.
Venus
You're
is
such a contrarian.
Yeah. All right. Let's start with the show. All right. Here we go. Hello and welcome to the Weekly Space Hangout for Wednesday, November 25th. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about a fossil galaxy discovered deep within the Milky Way, the fight to save Arecibo, and Chang'e 5 sets out to bring samples back from the moon. Joining me on my screen right now, I got Alan Versfeld. Alan, welcome back.
Hey. Yeah, good to be here.
And I've got, let's see, Nika Klimovich. Nika.
Hello.
There we go. Okay. And we got Dr. Kimberly Cartier. Kimberly.
Hey, Fraser. Happy podcast day, everyone.
It's like music to my ears every time. All right. Now, before we get on to this week's show, I just want to give a huge, gigantic reminder to everybody. If you enjoy the Weekly Space Hangout, but there are topics you want covered, guests you want us to bring onto the show, this is where we put the ball back in your court to join the Weekly Space Hangout crew, become one of the executive producers, and then you can have all of the reputation and clout in this industry to go out and line up guests for the show. Did you see a paper and you want to know more about some mission? Have you heard about some super celebrity astronomer that you want us to interview for you? Just join the Weekly Space Hangout crew, and then we will put you to work to track down the person that you want interviewed. Go to wshcrew.space. All right. Kimberly, you're on my screen right now. Let's get into the fight to save Arecibo. I guess, we haven't deeply talked about what's happened with Arecibo on the show yet. So can you just give us the
Sure.
update?
Right. So some of you may have remembered back in August, a cable at the Arecibo Observatory in Puerto Rico snapped and caused some damage to the 305-meter dish. We were all very sad and very heartbroken that there was damage to this dish. They shut the telescope down for repairs to do an engineering assessment of how to fix it, if it could be fixed. And during this assessment, on November 6th, a second cable snapped, and it was the main cable on the same tower that the first cable snapped. And this was totally unexpected. The cable snapped at about 60% of the amount of stress it should have been able to handle, which set off some alarm bells with all the two engineering teams that were doing the assessment of whether it could be repaired. The cables seemed a lot weaker than they should have been. And they completed the assessment, and just a couple days ago, the National Science Foundation basically came to the conclusion that they could not safely repair the dish with the funds they had available. And so they recommended the 305-meter telescope for decommissioning, which is very, very, very sad.
Yeah.
So that's what has happened so far. And there are a lot of very sad and hurt feelings about this because it's an iconic telescope. It's been around for almost 60 years. It has done phenomenal science and has been an icon and an inspiration to Puerto Rican scientists and students who want to become scientists for so long. And so almost immediately after the announcement, there was a petition started by supporters of the observatory to try and save the telescope, basically to petition the White House and Congress to reassess, get more funds there, try and save this icon.
And what are their chances?
I don't want to say their chances are slim. I personally would love to see it saved. My name is on that petition to save it. They need 100,000 signatures by the end of the month, and I think they're at about 18,000 right now.
Oh, really? Okay. All right. So,
sorry, within a month of when the petition started, not within till the end of November, which is a couple days from now. Sorry.
But right. But the point being, if you're listening to this and you want to save Arecibo, sign.
You still have some time.
Yeah. Okay.
I think you can just Google "Save the Arecibo Observatory" petition, and it's there. But if they get 100,000 signatures on this official White House petition, the White House basically has to give them a response to their request.
Okay.
Yes. It's one of those, if you reach a certain amount, they're compelled to reply to it, and they're also going to petition members of Congress, some of whom have been very, very supportive of Arecibo in the past. Arecibo has gone through many cycles of people trying to shut it down or trying to pull funding or basically like soft close it by, decreasing funding so low that it's basically inoperable. And it has been saved multiple times, but through massive public support, through support from individual universities and academics.
Yeah. And I think
it wouldn't be the first time it has been saved from the chopping block.
Yeah, I think that's my experience with this as well, which is like we've covered for years on Universe Today about how Arecibo has been on the chopping block, and like a fully operational, no cable broken Arecibo has still been a scientific instrument that people have said, do
we really need it?
Do we really $5 million a year to run this thing? Couldn't we spend that on something else? And so it has been on the chopping block for a decade that I know of. And so to then have this damage, I was amazed. I was actually really amazed that they started to commit, I think it was like $10.5 million to start the repairs, or at least to assess and figure out and begin that process and find out if it was going to make sense to actually do it. I was sure they were just going to throw in the towel right then, but then the next one happened, and now you're looking at tens of millions of dollars. But it's like it's a very dangerous place now.
So who
Yeah.
can sign this petition? Only
Everybody.
Americans?
Anybody can.
Anybody. That's good
Yes.
news.
Anybody and everybody who likes radio astronomy.
Yeah.
And
Should
did
do
they
it.
mention how much money do they need to?
I think part of the trouble is they don't have a dollar amount of what it would actually take to repair it, because the second cable snapped so recently, and it has raised some serious concerns about the integrity of the rest of the cables that are supporting the telescope. I think if it had just been the one cable that had snapped, or even just the two cables that had snapped, but both at the capacity that was expected, it'd be a pretty easy assessment to figure out, how much it would take to replace those two cables. But if all of the supporting cables are, if we have doubts about how much stress they can actually handle during this repair process, that's where it gets complicated and hard to assess what it'll actually take to fix it.
Right.
So how much of a gap then does this leave us if it's gone in what we could do before that isn't filled up by other existing telescopes like FAST or ESTEC and so on?
It does leave a gap, though not as much as it would have, say, 10 years ago, because there is the 500-meter telescope in China, which does similar science in a similar part of the sky. It has a wider field of view, and I think, Fraser, you just said that it's starting to be open to more astronomers around the world to apply
so China
for
has
it, right?
been China has been opening up the telescope for proposals from all nations to be able to do work on the instrument. So
there is some overlap there. It would leave a significant gap in radio coverage for just U.S. and North American based astronomers. Because I think the next biggest radio telescope the U.S. has is Green Bank, if I'm not mistaken, and that's 60 meters as opposed to 305,
right,
which is very different. So it would leave a significant gap here, and it's just it's basically like a 50% reduction in our giant radio capacity in the world. So I mean, everyone's always strapped for observation time, and this is the second largest radio telescope in the world.
And then the other thing that Sondi, whenever she was on the show, was always really glad to talk about was its capability as a radar instrument, really to send out a beam, see the bounce coming back, and use that to map out the shapes of asteroids that were flying past the Earth.
Yeah, it has done a tremendous amount of great science in radar mapping of asteroids, to mapping rotation rates and trajectories and finding things and pulsar science, and I mean, obviously,
So why
things as well,
but why they were trying to close it like even earlier before the cable snapped? Like, what were the reasoning if it's doing such a great job?
money, usually.
Okay.
It's usually a money thing, and the assessment of what it can bring to the table compared to other telescopes. I don't want to say there's any prejudice against the fact that it's in Puerto Rico versus like one of the mainland states. I don't want to say there's prejudice there, but the fact of the matter is that Puerto Rico does not have any congressional representation to fight for it as well. That is part of it.
Yeah, so it's like a really nice natural sinkhole depression. It's got the right shape for a very large radio telescope, and so it was chosen as that site. But I think, as you say, it's not like, I mean, when you think about, say, the Space Launch System or James Webb, that these, through the way the congressional system works, these experiments, spacecraft, etc., have the funds doled out to every state pretty much, and it's sort of like it's a big circuit.
Yeah, and I mean, if you compare, it's interesting you bring up SLS as well, because if you compare the amount of money, time, effort that has gone into making SLS work, and it hasn't yet, compared to the time, money, and effort needed to fix Arecibo, it doesn't compare. SLS is way more expensive and time intensive. It would take way more resources, but it is being built in Alabama, at a NASA center in Alabama, whose senator has a lot of power on a lot of committees, compared to Puerto Rico, which has none of those things.
Yep.
So
then
that is part of it.
So how will things play out from this point forward then?
So from this point forward, the teams of engineers are still assessing what it'll take to actually fix the telescope, try and get some ballpark estimates of money if they even want to go that route. If the petition gets enough signatures, one of the things they're asking for is a completely new engineering assessment from people who haven't looked at it before, and also the Army Corps of Engineers to take a second look at it. So that's we're sort of in a waiting game now. NSF can't do all that much to decommission it right away because of the pandemic and just the amount of resources they have on hand. It's a bit of a waiting game.
I mean, it is kind of interesting, though, when you think about some of the budgets that are spent on some of these new telescopes. When you look at, say, the European extremely large telescope, it's a $1 billion telescope. Now, it's going to directly observe extrasolar planets, but still, it's $1 billion. For $20 million, they could refurbish and bring back online a world-class 30 million, 40 million, like it does seem in compare, like if you could spend $40 million, $50 million and have, I know the number keeps going up every time I say this, but let's say it's some amount of millions of dollars. But
it's almost like you know how NASA and NSF work.
What would you be willing to pay to have a world-class observatory? Like it feels like it could be not just, it's weird. It's weird to me that such a powerful and important observatory has been let to go so badly. And it could be doing such important science work. And in fact, it should be getting the kinds of upgrades that you see on other telescopes. They're like, oh, we put a new receiver. Oh, we upgraded the computer system. Oh, we've got, we figured out a way to fine tune the harmonics, whatever it is, to get it better. More powerful laser.
Yeah, and I mean, we're talking a lot about, the excellent science that it has produced and it can produce, but I feel like we can never understate, just how much this telescope means to Puerto Ricans and just the hundreds and thousands of scientists and students and educators that this has inspired.
Yep.
And, all the kids who have gone to Space Academy there. And
yeah,
I mean, you cannot undervalue this telescope.
Yeah, remember Contact?
Remember Contact?
Yeah.
Anyway, if you're on Twitter, I highly recommend going to the hashtag what Arecibo means to me. I've spent many an hour there.
Oh, that's wonderful.
Just basically crying my eyes out.
Oh, yeah. Shannon Sterone wrote a great article on Slate this week about her thoughts about the telescope. I highly recommend do a search for Arecibo on Slate, and you'll find a really great article about it. And it'll be. I wish somehow Canada's robotic arms could fix this problem, but we just...
I don't think Canada can fix this.
We don't have an arm long enough to help. All right, let's move on. Nico, let's talk about the Chang'e 5 sample return.
5. Yeah, so China is attempting the most complex and ambitious mission today with the launch of Chang'e 5, and which will attempt to do something that haven't been done since 1970s, and that is to bring sample of the moon back to Earth. So 2 days ago, the 8.2-ton spacecraft was launched from Wenchang Space Launch Center atop of Long March 5 rocket. And according to a statement of Space Administration, the Chang'e 5 mission has several objectives, the scientific and the space engineering. So in the scientific field, the returned lunar sample will absolutely add new knowledge to the lunar history. So the mound is thought to contain rocks that formed relatively recently in geological perspective, so 1.2 2 billion years ago. And the Apollo samples, for example, they are 3 billion years old. So the Chang'e 5 samples could yield the youngest rocks brought back to Earth. And it shed the new light on the recent phases of lunar geology. So, and in terms of engineering, space engineering perspective, it will demonstrate and verify technical plans and apparatus, because the mission has several phases with really with a lot of challenges. So after separating from the rocket, the Chang'e spacecraft will use its own thrusters to make the 5 days travel to the moon. Then the spacecraft will release the lander that will land near the volcanic area, which is called Mons Rumke, in the northwest region of the lunar near side. And then the lander will drill and scoop the samples from the surface of the moon and pack it into the capsule. And the ascent vehicle on the lander will launch it back to the orbit around the moon. Hopefully, it will have 2 kilograms of lunar material on the board. And finally, then the orbiting spacecraft will catch this capsule and return it to Earth, to Mongolia. And the whole mission will take 23 days approximately.
Wow, that's so quick.
So
I did not realize that it was 23 days.
Yeah, so we're going to have a sample back from the moon in 3 weeks.
Mid-December.
Yeah. Yeah.
That's crazy.
And the reason is also... Yeah.
Sorry, go ahead.
No. The reason for this short term is just the spacecraft has solar panels and it can only work for 1 lunar day, so 2 weeks. So there's one chance.
That's so cool. I'm so used to like it being like, oh, it'll take us a year to get there and then we'll be there for a year and it'll take a year to come back. So it's like delayed gratification there. But this is so it's like
there's a couple of cool things that have been going on. One thing is that the data coming back from the mission is completely unencrypted, and so people around the world have been receiving the data coming back from the spacecraft. So we're seeing pictures coming back from the mission already, and not released photographs from China. They're just people are decoding the transmissions and actually showing the pictures, which is pretty cool. And then also, NASA has got an agreement to get access to some of the samples as well, or see the data on the samples as well. So I think, it's definitely going to be more of a collaboration than the Chinese moon missions have been to this point. Although I've got to say, for the last mission, it's been, they put a lot of information out directly.
The others also supporting the operation, so I think that Europe will get some data as well. It's not clear.
Oh, that'd be great.
Mentioned who will get what, and there's no information on that. But they said after the sample is returned, they will put some guidelines. How they share.
So can you talk a little bit more about you mentioned that the place they're going is younger. So what do you know about the site that they're going to?
So there's the volcanic area, the mold, that is Mons Rumke, and I know that there were already several missions to that area, but this part of the area holds these special rocks that are theoretically younger compared to the all previous sample results that we got so far from Apollo, from Luna, Soviet's missions, and so that is pretty exciting for everybody to understand whether the assumptions that we made before are really the real ones. So that the geology is the way it is, how we know it from previous samples. So it may, with the new samples, we will have completely different story.
Right.
And the no, okay, that's it.
No. I think that's great. So I mean, I guess to have a surface that is, say, just like 1.2 billion years old compared to some of those older lunar regions that the Apollo astronauts had brought rocks from. What do you think they might be able to learn from these rocks?
What could they, please repeat the question?
Yeah, well, like what could they learn? What kinds of information could you find out from these younger regions of the moon?
I assume that what happens later to the to the volcanic magma, and after the impacts okay, I think the first part, I cannot reply to this question completely. I need the help from others.
No problem. Kimberly, what do you?
Yeah, so I was going to say, I think one of the main things we can learn is, differences in solar weathering across the moon's history. And as Nika said, how the rocks have been altered after this lunar magma phase, how cratering has changed and how that may have altered the surface chemistry. And I think part of what will really help us, pin down this recent lunar evolution, what's happened in the past billion years or so, is that I think this mission is not just, scooping up surface samples, which is sort of what's been done in the past, but they're also going to be drilling into the surface. They're going to be drilling about 2 meters down and extracting rock cores from this area, which I don't think we've ever done off the Earth before on anywhere else but the Earth, just, extracting rock cores from a surface. So you're going to see not just, what rocks you can pick up on the surface and like the regolith, which has been crushed to bits. But you'll be able to see 2 meters of rock layer, of rock deposits, from the surface going downwards to, really see the subsurface geology and pin down some of the physical processes and how the rocks, have changed, have been altered, interacted with each other, if there's water there, what kind of chemistry is happening.
I suppose that's a pretty big deal in seeing what's under the regolith for the first time.
Yeah. I think my favorite part is the fact that we're going to get rock cores back.
Yeah.
I mean, samples are awesome, but rock cores, I'm not sure have been done before.
Yeah, so I mean, the last time was 1976 with the Soviet Luna 24 mission. So it's been a long time since we've had a sample back from the moon.
And the uniqueness is also that is autonomous sample return, which has not really happened before, because during the Apollo mission, there were people collecting things, for example. And drilling down is definitely first on the moon. So a robotic sample mission.
Yeah, very cool. I'm very excited to see what happens with this. Thank you so much, Nika. All right, Alan, what do you got for us?
Yeah, this is a changing scale now. Astronomers working on the Apogee project, which is the Apache Point Observatory Galactic Evolution Experiment, part of the Sloan Digital Sky Survey. They reckon they have identified the remains of a galaxy that the Milky Way collided with, interacted with, and eventually absorbed 10 billion years ago.
Wow.
Some 5 billion years before the sun was formed, which is amazing. It's such a long time ago. And it's kind of technically intact, right? Basically, they have, this isn't the first time we've identified stars from previous mergers, but those are generally in the outer regions where they are you can see them. They can be discerned from the general background of the Milky Way. Whereas this structure, which they've decided to call it Heracles, after the Greek hero, is mainly, it's inside that central bar bulge of the Milky Way.
Wow.
And Apogee collects spectra and astrometry using near infrared, so it's able to see through all that dust. And it was a 10-year project, analyzed 500,000 stars.
Wow.
I know, right? So many. And
to like 10 years to figure out this is just incredible.
And they identified quite a large number of stars which are got such a different chemical makeup from what we're used to seeing in the Milky Way that they must have come from somewhere else. And I'm not clear what the modeling was to figure out how long ago the collision happened. And they sort of hedging the proper science talk, we may have found could have,
possibly,
On the other hand, they certainly have to publish, and I just think it's quite amazing because this thing is making up a third of the Milky Way's mass. Wow, so it's big. This was a major event, and from what I understand, spiral galaxies generally have fairly quiet early lives, so that would make this quite unusual. This was a major event a very long time ago in our galaxy's history.
How long ago did it happen?
10 billion years.
10 billion years ago.
Yeah.
And the fact that they were able to piece together the movements of these stars and collect it all into one big object that's just not fully digested. Like, it's weird to me to think that even before the sun formed, this collision had happened 5 billion years earlier than that, and yet it's still getting digested in a way that you can detect it.
I suppose it must be pretty stable by now. It's just a part of the Milky Way now, but you can still identify that there are different structures, and it's still fairly homogeneous. It's still on the illustrations that they give. It's a definite sort of elliptical shaped clump, taking up a large portion of that central bar of the Milky Way.
So you mentioned that the chemistry of these stars is, noticeably different from the Milky Way, like Milky Way born stars. What about the chemistry is different? Is it like, are they missing certain elements or?
Yeah, those are details I don't have, but I can only imagine that must be what it is. I mean, chemistry is maybe the wrong word to use for a star. There's no chemicals in there. It's all elements. But yeah, it would be different from different populations.
Yeah, I guess we have to read the paper. I'm not sure what the. I mean, they say in the press release that they are. We looked at a few hundred had strikingly different chemical compositions and velocities. The stars are so different that they could only have come from another galaxy. But I don't know.
I'll have to follow up on that.
Yeah, but I'm not sure what the different chemistry is.
Yeah, that's really fascinating, especially that it took place when the Milky Way was so young. I mean,
the universe was young then.
The universe was young, right?
Yeah.
It's only a couple billion years after the universe was formed, and the Milky Way couldn't have been more than 1 billion or 2 billion years old at the time.
I was mentioning this before the show that there was this study that came out a couple of weeks ago as well that showed off all of the different galaxy mergers that made up the Milky Way, that they were able to track all the globular clusters, and be able to piece them back to all of the individual mergers, because each one essentially, if you've got a bunch that are made of the same stuff and they're following a very similar orbit, they came from a galaxy. And they were able to figure out, these two galaxies collided together and those came together to make a bigger one and a bigger one. But it is amazing that you get this beautiful grand spiral design as the final outcome. And yet we know that when Andromeda and the Milky Way come together, we're going to get a giant ball of red stars. So, it's got to be the right size collisions to get you just the perfect, nice spiral shape before you get the mess. Super fascinating. Very interesting. All right. Well, we're going to shift over to the interview portion of the show. But before we do, I'm going to bid my co-hosts adieu because they don't have to stick around for this part. So, Alan, you're on my screen. Tell us what you're working on and where people can find out more.
So I'm hoping to resume finally the third season of the Urban Astronomer podcast. Next episode will be an interview with an astronomer currently in the Netherlands, South African born. And you can get to urban-astronomer.com for the subscribe links and to see show notes.
Fantastic. Nika.
Yeah. So I am currently working with a new space network in Germany called Gaia Aerospace. And they have like
any relation to the mission?
Nope.
Okay, all right.
Just a coincidence. That's the same name. And they do a lot of networking events, of course, but they have also their own projects. And one of these projects I mentioned, I think last time, that they're working on this spaceport and on the launcher. So that's currently what I'm doing. And if there are any online events, I will post it in Twitter for sure. And you guys have my Twitter.
Kimberly, apart from reminiscing about the Arecibo, what have you been working on?
Oh, does it leave time for anything else? I didn't realize.
No.
I've been frantically getting ready for the AGU fall meeting, which starts up next week. There'll soon be a deluge of Earth and space science news.
But it's going to be like
it's
online, right?
All online, all virtual for 3 weeks. There's so much science. Oh my gosh. And I have a couple stories I've already written and a couple more that are already in the works. So keep an eye out for stuff from me about Uranus and ocean moons and about exoplanets and mantle dynamics and about drought. Mm-hmm. And all that'll be on ES.org and on Twitter.
Fantastic.
At Astro Kim Cartier.
Excellent. All right. For those of you who are listening right now, I've got an interview with Wallace Arthur, author of The Biological Universe. We're going to be talking about life in the universe tomorrow at 8 a.m. on my YouTube channel. Of course, another open space coming up on Monday. Lots of other good stuff happening on Universe Today. I'm pleased to announce that Alan Boyle, one of my mentors in the space journalism industry, has taken up the mantle and started writing for Universe Today again. So he covered Chang'e 5 for us on Universe Today, and I'm sure we're going to be seeing more from him in the future. So I'm super excited. So Universe Today has got even more great writers and more great material coming out all the time. Buckle up. All right. I'm going to say goodbye. So I'm going to put everybody back on the screen there. There we all are. So I'm going to say goodbye to everybody. Thanks, guys, for joining us. Nika, Alan, go to bed. Kim, I guess you're in the almost bedtime for you too. So everybody go to bed.
Almost 9 o'clock. It's almost bedtime.
Yeah, I'll keep going from here. And but thank you for joining me this week.
Great.
Thank you. Bye.
All right. Back to me. Let me queue up my interview. All right. Here we go. Wow, I'm wearing like the same outfit. Okay, perfect. It's as if I recorded earlier today, which I didn't. Okay, here we go. All right. Thanks, everybody, and enjoy the interview. It's a good one, so don't leave. All right, joining me this week on the Weekly Space Hangout is Olivier Witasse from the European Space Agency. Olivier, welcome to the show.
Yeah, thank you. Very, very nice to meet you.
So the question I always like to ask people is who are you and what do you do?
So I am Olivier Witasse. I'm working at the European Space Agency in ESTEC in the Netherlands, not far from Amsterdam. And I am the project scientist of the JUICE mission. So JUICE is for Jupiter Icy Moon Explorer, due to launch in 2022. I think we'll talk about that later. And as project scientist, I am responsible for the scientific aspects of the mission. And yes, I'm working with the scientists to make sure that the mission will be a success and that in 10, 15 years from now, we will have great discoveries, great images, etc.
So, I mean, it's funny. People are very familiar with the Europa Clipper, and yet I always try to match the two together. I talk about the Europa Clipper, and I also talk about JUICE at the same time as a whole separate mission that's going to be examining not only Europa but other Jovian moons. So, can you talk a bit about what the JUICE mission is going to be doing?
Yes, so the JUICE mission is, I think it's a fantastic mission. It's a big mission in ESA, so one of the biggest budget for a given mission. And it's a broad and interdisciplinary scientific mission. So we are not only focused on one aspect, like sometimes in other missions. So because when we go to Jupiter, it's not very often, as you can imagine. So when we go there, we try to do the maximum. So the goal is really to explore the Jupiter system as a whole. And of course, our idea is to focus on the three icy moons, which are Europa, Ganymede, and Callisto, because we are very interested into those moons because we have good reason to believe that there is a lot of liquid water inside the moon. It can be a bit strange to think about that when you see the moon, it's ice crust. And inside the moon, we have maybe more liquid water than on Earth. So it's very fascinating because of habitability, life, etc. So we are going to study those three moons with a particular focus on Ganymede. That's our main target, the biggest moon in the solar system. And because we will be around Jupiter for many, many years, we are also going to study the giant planets, so the atmosphere, the magnetosphere from far away. So really the idea is to study the whole system with a particular emphasis on the three icy moons to understand whether there could be habitable place around a gas giant.
So let's sort of deal with these worlds one at a time, because again, I think everybody is fairly familiar with how exciting Europa is. But let's talk about Ganymede. Why is Ganymede such an interesting world and a target for JUICE?
Yeah, so it's true that in the Jupiter environment and the Jupiter system, Europa is one of the most interesting targets because when we started to study the liquid ocean, the properties of this liquid water in Europa is maybe very close to the Earth ocean. So that's why Europa is a very interesting target because it offers the most exciting target for astrobiology. And Ganymede is less known, of course, because Europa is really the most interesting target there. But what we learned as well is that there is also a lot of liquid water inside Ganymede. So that makes also an interesting moon in the Jupiter system. It's the biggest moon of Jupiter and the biggest moon of the solar system. So it's a kind of mini planet. Yeah. So it's also quite interesting in that sense. And there is a very interesting aspect with Ganymede is that there is an internal magnetic field, which is not the case at Europa.
Right.
So if we think about rocky bodies like Earth, or the terrestrial planet, there are only three bodies in the solar system, three rocky bodies with magnetic field. So the Earth, and we are happy that there is a magnetic field that can protect us from the solar activity. There is Mercury, and there is Ganymede. So it makes a very interesting moon because a big moon, mini planet with an ocean inside, plus a magnetic field. So that makes a very interesting target, and we decided in Europe with the European community and the European Space Agency that it should be our main target. And so from the scientific point of view, as I said, it's a very exciting target. Also from the technical point of view, it was easier for us in Europe to focus on Ganymede because Europa, even if it's very interesting, unfortunately, Europa is a little bit too close from Jupiter. Mm-hmm. And that means in terms of radiation environment, Europa is much more complicated to explore for a spacecraft.
And so
because yeah.
It's kind of interesting, right? That Ganymede has an internal magnetosphere like the Earth.
Yep.
And so that would be more protective, but it's also farther away from Jupiter, and so it's experiencing less of the trapped radiation from Jupiter. So it seems like a potentially more habitable world than, say, Europa might be.
Exactly. So that's why for us it's a very interesting target, because sometimes we hear that Europa is more interesting. So Europa Clipper is maybe going to a more interesting target. So why do you go with JUICE to Ganymede? But in fact, as I explained, I think it's a very interesting place, and maybe we will get some surprises from Ganymede. Who knows? The main difference is, of course, the distance to the giant planet. That's why Europa, being closer to Jupiter, experiences more gravitational pull and more heat inside. So that's why it's a more active moon.
Mm-hmm.
Ganymede is a bit further away, so much less active. So that's why, in principle, it's less interesting for astrobiology. But because of the ocean, because of the radiation environment and the internal magnetic field, that makes, to me, a very interesting place to explore.
You talk about the fact that it has less tidal heating, less than Europa. What do you think, if Europa, say, has this liquid ocean under 100 kilometers of ice, what do you think that the structure of Ganymede is going to be like?
So the internal structure of a moon or a planet, it's always very complicated to study because we don't go inside. So it's always a very complicated question. What we think of Ganymede is that there is an iron core which generates the internal magnetic field. That's in the middle, that's in the center of the moon. Then on the external side, we have the icy crust, which can be maybe 40 or 50 or even more 40 or 50 kilometers thick, that we don't know. We are going to study that in detail. And in between the crust and the iron, there is different ice layers, because we call them icy moon, because they are mainly made of ice. And sandwiched somewhere between some ice layers, there is this liquid water ocean. So this is more or less what we think about the internal structure. And with all the data from JUICE that we are going to get in 10, 15 years from now, we are going to, for sure, to understand better the structure. So, for example, is our ID correct? So did the different layers inside the moon? And then what are the different sizes? For example, how deep is the ocean? How big is the liquid core? Etc., etc. So that we are going to get more information with the data. But we have the overall big picture, but we are missing all the details.
Yeah. So to figure out those details, what instruments will JUICE be bringing to the system to be able to study? Anything like, any new tools in the toolkit?
Yes, so we have, so because, as I said, we don't go there very often. When we plan a project or a mission to go to Jupiter and the icy moons, we put as much as possible of instrument to make sure that we are going to get the most science out of it. And we have, with JUICE, I think we are well equipped. There will be 10 instruments. So 4 remote sensing, so 1 camera, and then different instruments to use in different wavelengths, like visible, infrared, UV, and millimeter wavelengths, just to understand the composition of the surface and to take images to understand the geology and the world there. Then we have 3 geophysics instruments, a laser altimeter, a radar, and the radio science to probe the gravity of the moons, and 3 in situ measurements, instrument to measure the environment, so the energetic particles around the moon, and the magnetic field and electric field. So we really cover all the basic principle measurement when we prepare a planetary mission, because we want to make sure we understand everything. So from remote sensing, geophysics, and in situ.
Oh, so then after studying Ganymede, you'll study Callisto. What maybe is different? What differences are you expecting from Callisto compared to Ganymede and Europa?
Yeah, so Callisto, just from the mission design point of view, we are going to have something like between 12 and 20 flybys of Callisto.
That's great.
So every time we do a flyby, we get a lot of data. So, but it will not be like Ganymede. Ganymede at the end of the mission will orbit Ganymede, so we'll completely map Ganymede. Callisto, it will be a few flybys, and Europa only a 2 flybys. So just to give you the
Right.
difference between the 3 moons, we are not going to get the same amount of information for the 3 moons. So a little bit of information on Europa, an interesting set of information for Callisto, and a complete set for Ganymede. And for Callisto, so Callisto is much further away from Jupiter compared to Ganymede. So that's the 4th Galilean moon. So in terms of radiation, it's much further away in terms of gravitational pull or tidal heating. So what does that mean? Is that unlike the other moons, Callisto, we can say it's relatively dead from the geological point of view.
Right.
It did not evolve much over the last 4 billion years. And when you see the surface, you understand exactly what it is, because you see a number of craters. It's heavily cratered, very similarly to our own moon. So that means the surface is very old, because the more craters you see, the more old the older is the surface. So that means it's a dead body. So it's quite interesting to compare this dead but big body. It's more or less the same size as Ganymede. It will be very interesting to compare that with Ganymede, which is more an evolving moon, comparing to Europa, which is even more active with the astrobiology perspective, and even to compare with Io, which is a completely active moon with volcanic activity on the surface. But still, even if we think it's a dead body, we have also some reason to believe that there is possibly an internal subsurface ocean also inside Callisto. Some data from the NASA Galileo mission 20 years ago revealed that it's possible. The data is not very, very clear. So it will be very interesting with JUICE to confirm or not the presence of liquid water inside Callisto. And if there is liquid water inside Callisto, how is it possible?
Right.
So that's why it's very interesting also to study Callisto.
I mean, I guess it is interesting with Europa and Ganymede, the history is erased, while with Callisto, the history remains longer. And so you can kind of hope that what you see happening over on Callisto probably happened on Europa and Ganymede, in the same way that we look at the moon as a way to understand the Earth, even though the Earth has wiped away all of its craters. So
yeah, no, correct. In fact, the connection was less good. Sorry.
Oh, okay. Sorry. So let's just talk about now the launch date. So when do you launch? Whoop, did I lose you there? When does the rocket launch? And how long will it take to fly out there?
So we have a launch window in June 2022. So that's our baseline. We work to meet this deadline. We have a 1 week launch window. And if we manage to launch on time, it will take 7.5 years to reach Jupiter.
So far.
Because JUICE is a big spacecraft, so 5 tons. And we use a very powerful rocket, which is Ariane 5, but not powerful enough to send us directly to Jupiter. So because the direct route with a very powerful launcher will take 3 years, something like that. With our current mission design, it will take 7.5 years. So rather than going directly to Jupiter, there will be a 3 orbit around the Sun, when there will be gravity assist flyby of the Earth, Mars, and Venus to get the necessary energy to reach Jupiter, and then we arrive at the end of 2029. So we have to be patient.
Right. And how long do you expect to be in the system before you wrap it up?
So then, once we are at Jupiter, we'll orbit Jupiter for 2.5 years, something like that. So we will orbit Jupiter. We'll make the flybys of the 3 moons. And then 2.5 years later, we'll orbit Ganymede for something like almost a year. And once we orbit Ganymede, we are there, we cannot escape anymore. And when we have no fuel or where the mission is not working anymore, at the end, we'll eventually impact Ganymede. So all in all, the mission is baseline to last something like 4 years in the Jupiter system, including one around Ganymede. So that's the baseline. We will see how it works. If it works well, if the spacecraft is performing well, if we have enough fuel, then we might think to extend the mission, but we will see once we are there.
Well, is it powered by solar, or are you using an RTG as well?
Yeah, in Europe, we have to use solar panels.
Right.
We cannot use RTG, so we have a huge solar panels, 85 square meter. If you find images on the web, you see a special shape. It's that makes the design and the image of the spacecraft quite interesting.
Yeah, well, I know with Juno for a while there was the only solar-powered spacecraft out there, and I think you get something like 1/9 the power. I forget the amount, or is it 1/25th? Anyway, like a fraction.
1/25th.
1/25th the power of what you get at Earth. Yeah. So your solar panels have to be 25 times as big to be able to deliver the same kind of power, which is very big solar panels, which is why the spacecraft, as you say. Yeah.
That's a challenge.
Yeah, absolutely. Well, fantastic. Thank you so much for taking the time to chat with us today. I'm sure everybody's going to be seeing a lot more information over the coming years as we lead up to the launch, and then we wait and wait and wait, and then we will actually see the arrival at Jupiter, which is going to be really exciting. So again, thank you so much for taking the time to chat with us today. We really appreciate it.
Thank you for your interest, and follow the mission.
We will. From the European Space Agency's website, I know there's a lot of great information there.
Yeah, and Twitter as well. So
perfect.
There are many possibilities.
All right. Well, good luck. Good luck with everything. I hope there's no delays, and hurry to the launch pad.
Thank you.
Thanks.
Perfect. Bye-bye.